Okay, so good morning. My name's Scott Gearon. I've been working for Galebreaker now for 7.5 years. I oversee our ventilation products, so our side curtains, our tube ventilation. And so what we often see is most of our products are fitted retrofitted to buildings, because what tends to happen is often a building is designed for general purpose, not necessarily specific for calves. And so it's kind of the wrong way round. What we need is people to be designing buildings that are right for the calves in the first place, to put our products on in the beginning, and then you can create the right environment for those calves right from day one. So today I'm just going to run through some of the key points of what you require for your calf building to create the right environment. So overall calf health really comes from 3 different areas. The first one is the calf, so you're looking at your immune system, your colostrum management, genetics, whether your dam has been heat stressed, those sorts of things. The second one is pathogens, so as been discussed previously, these are within the environment itself or within the animal. They're inevitable to some extent, but they need to be managed. And the third one is the environment, which is just as important. And so the areas that I'm going to look at today are ventilation, drainage and flooring, stocking, feed and water, labour, lighting, and the building itself. And so I'm going to go over these quite quickly, but just to cover the main points. So why do we need to focus on the calf environment? Well, we want to give the calves the best start. We all care about the calves, which is why we're all here. But if we can give the calves the best start, they will be developed better, they will be able to produce more milk in the future, and we're able then to have a good herd that is able to have higher milk yields, shorter times between calving, and then we can have a sustainable farm. And ultimately what we want to get to is to have success year after year after year with good sustainability. So, ventilation. What we want is good ventilation. And so good ventilation replaces the stale damp air within the building, replaces this with clean, fresh air in the right volume and the right speed, which is the important part. Ventilation reduces the pathogen builder, and then that means you're less likely to have respiratory disease. You remove the humidity from the building. Again, pathogens love a humid environment, and also this can help with ensuring you have dry bedding. And the way in which to assess your building is to perform a smoke test. So allow some smoke bombs to go off within the building, see where that air comes into the building, how it circulates, and where it leaves. And this will give you a good idea as to how well it's performing. Now, calves themselves don't produce any heat, so you don't have any stack effect. There's no heat, the dirty air doesn't rise up to an outlet, therefore you have poor circulation of air within the building, and they continue to breathe in that dirty, contaminated air. And so signs of poor ventilation: you can smell ammonia within the building, condensation and cobwebs on your building structure, or preferred lying areas. So if cows always lie in a certain area, there could be a good reason as to why they don't go in that other area, which could be drafts or dampness. So it's a good idea just to have a look and see how your calves behave within the building. So how the air enters the building: fresh air comes through in an inlet, and you're looking at having 2 times the size of the outlet for your inlet to create the right amount of air going into the building. But you want to have solid walls at around 1.5 to 2 metres. The reason for this is that then you're not having a draft going on the calves when they're led down. So there's different materials that you can use for your inlet itself. So you can use Yorkshire boarding, space boarding, or metal cladding. Now, Yorkshire boarding is where the boards are offset from one another. This prevents driving rain from going into the building, and also helps reduce the airspeed as it enters the building, because the air has to funnel through. Really good on the prevailing wind side, at preventing that wind and that rain going in. Space boarding are just boards alongside each other. Now, unfortunately, this doesn't stop the driving rain going straight in, and actually also the airspeed increases as it passes through between the boards. So this is not good for the prevailing wind side, but is okay if you have a sheltered side of your building where you don't have a lot of wind going through. The third option could be metal cladding. Now again, this is really good at reducing the wind speed going into the building. It can get quite warm if it's exposed to the sun, which would then warm up the internal temperature of the building and may become clogged if you have quite a dusty environment outside. The fourth option is to go down a mesh product route. So you could go with a fixed mesh product, or you could go down an automated side curtain route. Now this is really good because these can control the environment during the winter and during the summer. So during the winter, these would be fully closed. You could use a mesh fabric, which would allow air to pass through and has similar properties to Yorkshire boarding, but then they can be opened during the summer to get extra ventilation through so the building doesn't become too hot. These are also controlled through wind and rain to make sure you don't end up with strong winds and lots of rain going into the building. So these offer the flexibility that other fixed solutions don't offer. So when the air goes into the building, it needs somewhere to escape, and we want that dirty air to escape ideally out of the top of the building. We want it to go away from the calves as high as possible. Now the outlet and its importance is often overlooked with building design. And so what we need here is something which is ideally like a light ridge, which will allow the dirty air to escape and also allow continuous light inside. Now I've given an example of 0.04 metres squared per calf. Now this is the absolute minimum. If you have larger animals which might go into the building in the future, or more calves as you grow your farm, then you would need to consider that when designing your building. So this is the absolute minimum, but it'd definitely be worthwhile thinking about how you're going to use that building in the future as to whether that outlet should be bigger. A lot of general purpose buildings have crank ridges. Now these are really not suitable for cow buildings in general. They only have around 20% of the required opening space that is actually needed. And so what you're much better off with is a light ridge or some protective ridge, which would actually give you the size that you need. So what do we actually require? Well, the fresh air going into the building needs to be at the correct volume and the correct speed. And so during the winter, we're looking at around 0.25 metres per second, and in the summer, around 1.3. Now, this is at calf height, which is 1.2 metres off the ground. Anything less than this is effectively still air. Now, what that's not doing is pushing that dirty air out, and that's what we want to do. 0.25 in the winter pushes that dirty air out of the building. Anything about around 0.3 is considered a draft. And what you'll notice when the calves that are lying in preferred areas is that if you were to go and measure that airspeed, you would probably find that it would be significantly above 0.3 metres per second. We also need to ventilate the entire volume of air in the building. So in winter, that's around 6 to 8 times per hour, and in the summer, that's around 40 to 60 times. Now, we live in a maritime climate in the UK. Today's nice and sunny, tomorrow might be chucking it down with rain and gales, but what calves really need is consistent ventilation all year round. Now, one thing that can really do that for you is if you use PPTV or tube ventilation. So how this works is it draws fresh air in from outside, it goes down a tube and is distributed across the area where the calves are. It then creates an artificial stack effect by pushing the clean air in and forcing the dirty air out. And then that should go out through an outlet at the top. And these run 24/7. So regardless of what the weather is like outside, these will be providing the fresh air that you need within your building all year round. One key point with tube ventilation is that everyone's building is slightly different. Where the calves are positioned in the building, the layout, the size, the volume is all unique. So you must look for a tailor-made option. Off-the-shelf tubes are too general. They won't necessarily provide the right air changes or volume changes, and they might give you too high an airspeed. So that's something to be very careful with. Calves require a dry environment, and so if we have a damp environment, they're more susceptible to cold stress, and you're likely to have an increased pathogen load because pathogens like a damp environment. So what you need to do is provide deep straw bedding. So as you can see from the photograph there, the calves are led down in deep straw. Way in which to ensure that you have enough straw, or to check, is to try a dry knee test. And so a dry knee test, you simply kneel down in the straw. If you end up with wet knees, you don't have enough straw bedding. And so that is the best way to check this. The flooring itself, you're looking at a 1 in 60 slope over the whole building area, but you're actually looking at around 1 in 20 within the pens themselves. And this slope helps all the moisture drain away to the front of the pens. At the front of the pens, you should look to have a drainage channel, which is covered. But as you can see in the photograph in the bottom corner, this is quite dirty. Therefore, you need to make sure it remains clear, or otherwise that moisture will just build up in the pens. If you have slatted floors, you can also have this as an option. But if you have too wide a drainage channel, be aware that actually the moisture is not really that much. Therefore, you might have significant amounts of moisture left in that channel and then ammonia coming up through the slats, again, which is not ideal. So calves must have some kind of visual or tactile contact with each other, and initially they will be kept in individual pens, but as they get older they'll then move to group pens. And so this should be around 8 weeks, but ideally sooner. You can have around 12 in a group up to 8 weeks, and then around 20 over 8 weeks. Now, one thing to bear in mind is that, and it's becoming much more common, is that initially calves are put in individual pens, but studies have shown that actually allowing calves to go together around 3 weeks of age can actually provide cognitive benefits to the calf in its younger days and once it gets older. So what you'll see on the market now is more individual pens with a divider, and after 3 weeks you can remove the divider, and then the calves are allowed to group together, and then they'll end up progressing better once they get into larger group pens. The one thing to be careful of is mixing calves of different ages. So whilst younger calves are more susceptible to picking up disease off older ones, also bear in mind that even though older stock might be close by, it's best to keep the two separate. You do not want older stock passing off pathogens to your younger calves. It's also really important to look to disinfect and clean your pens and give them time to rest in between as well. So if you're designing a new building or you're laying out a building, look to have a pen area which is free, and therefore you've got enough space for rotation. So calves must be fed at least twice a day and have access to clean water, but where you put your water troughs is also important. These should ideally be above drains and not over the bedding. So any spilt water will then go onto the straw bedding, creating a damp environment, which is not what we want. So if you can place these at the front, that would be best. More and more people are using auto feeders. Now, auto feeders have a self-cleaning system, but you need to ensure that these are on a plinth or close to drainage, so that all that dirty milk and water has somewhere to go. And as you can see in the photograph there, it's not quite right there. You can see that some of the water is working its way back into the pen. So really what you need is to ensure that that dirty water flows away and then moves away from the bedding area. So how you design your building from a labour point of view is also really important. If tasks are difficult or time-consuming, they're less likely to be done. So where you put things like your feed kitchen, your new straw bedding, your milk powders, etc., is really important. And so if you can have a system whereby it's really quick and easy, you'll have increased profitability, you'll have improved staff satisfaction, and then this allows you to focus on other proactive tasks. So if you're designing a new building, having your feed kitchen in a separate building quite some way away means people are less likely to spend the extra time cleaning those buckets out thoroughly like they need to, because they've got to walk back. So potentially what you could look at doing is having the feed kitchen at the end of the building where all the calf pens are, or even better, potentially put it in the middle of the building, and therefore you're limiting your distance walking to and from the pens. Lighting within the building is also important for the calves. They need to make sure that they have a daylight period and a night period. So you're looking at 16 to 18 hours or around 200 lux during the day and around 6 to 8 hours below 30 lux. And the reason for this is that it improves the hormone balance and therefore can increase weight gain and also milk production in the future. Now this can be done through natural light or artificial lighting. So one key area which is often overlooked, and we see this an awful lot at Galebreaker, is the orientation of the building. And so what we frequently see are buildings which are orientated with the prevailing wind hitting the gable end, as you can see in the top image. And what happens there is that the air doesn't enter the building from the side, it hits the gable end, and then all you have is a circulation of dirty air within the building. So what you really need is your building to be perpendicular to the wind, like the image in the bottom there, and the air can pass through the side. But also what happens is, when it passes through the side, it'll also go across the top of the ridge. And if your ridge is designed to suck out the air out of the building, you're getting the max performance out of your ridge. If it was to be like the image across the top, you're not utilising that ridge fully. So also bear in mind that what you really want is your calf building to be upwind of other buildings. So if it can be upwind, you're less likely to have that dirty, contaminated air going from older stock into your calf building. You're getting as much fresh air in there as you possibly can. Ideally, again, not in close proximity to other buildings, because if your calf building is first, you're then hampering the ventilation on the remaining buildings there as well. So if you've got your high yielders in the other two buildings, you're then going to restrict the ventilation into there. You're then probably going to have heat stress issues with your yielders as well. But also bear in mind that where you position it on the farm, you've got other surrounding issues like trees or banks. Again, that can hamper the ventilation. So the exterior design of your building, you're looking for a roof slope of around 17 to 22 degrees, which is ideal for ventilation and better than, say, 7 to 10. You've also got lower solar gain and you've got lower snow loadings. Now, the material you choose to use, fibre cement is a really good option. This actually reduces condensation inside and also creates a more stable environment with regards to temperature over such things as tin cladding, which can overheat the building during the summer and also create condensation during the winter. To have the natural light that the calves need for 16 to 18 hours a day, roof lights are a really good option. Around 10 to 15% of the roof can be covered, maybe up to 20% on the north side, but be very careful on placing too many roof lights on the south side, or otherwise you'll just create a greenhouse effect with inside the building, and then your calves will get too warm and potentially suffer from heat stress. So within the building itself, look to use materials that are really durable and easy to be cleaned. So concrete, steel and polymers, plastics are really good for this. So as you can see in the top photograph, people are starting to use plastics for their gates and their dividers. Also now look to have solid dividers between pens. Now this prevents nose-to-nose contact, which means you're less likely to have disease being passed from one group of animals in one pen to another. What you can also do is, because concrete can be quite cold, especially during the winter, is to put plastic, as you can see at the top, against the concrete wall, or foam insulation. And then this just helps increase the temperature within the pen a little bit more than what you would have if it was just concrete. Or you could go with the other option, which you see below, where people use straw instead. And this is really good at creating a slightly warm environment for those calves. So there's a variety of different building types that people can go for. You can have an A-frame building, igloos with a covered area, individual pens, a mono-pitch type building, general purpose type building, or you can go for a more cost-effective polytunnel type building. Now, which one of these suits you is really down to you as an individual. All of them have got pros and cons, none of them are perfect, but what works for you, for your calving pattern, for your labour, for where it's positioned on the farm, etc., is very much down to you as to what actually will work best for you. But everything that I've discussed today, whilst some of it might be very specific, generally speaking, the principles apply to all of them. So take-home messages for today. Plan and consider all your options. Go around, visit your local farmers, see what other things they're doing, discuss with them all the things that are really good, but also discuss the things that they find which are not so good. And maybe even visit people who have got a system which you haven't previously thought about, because you never know, that might be the system that works for you. The drainage, ventilation and stocking are really important, but so are all the other things that I've discussed. If you pick on one or two of these things and make them really, really good, and you don't have something else which is functioning quite so well, it still could have a detrimental impact to your calf health. So really look at all of them as with the same level of importance as each other. Tube ventilation really will benefit majority of buildings out there. And so because of the environment, the climate that we have in the UK, if you can have a consistent environment, consistent ventilation with tube ventilation, this will certainly help. Make the most of grants and subsidies. So there's a lot of grants going around at the minute, and a couple of times a year there's grants out there for tube ventilation. If you can look to utilise these can really help you with your initial outlay. And also monitor any changes that you have. So any changes that you make, see how they improve, if they do or don't, and if they don't be scared to make further changes in the future as well. Thank you.